Hey, hello friends. Welcome to the second video in our series around regression. We are using regression to learn about how to build predictive models, predictive analytics. Okay, so I'm going to do a quick recap of the session 1 and then we're going to deep dive into the next step, which is step 3, where we are going to talk about deeper understanding of the data. So we started with regression, we're essentially saying it's an approach where we can quickly find the relationship between two attributes, two data points, and what is the strength of the relationship. In this case, we are using California housing data, which is essentially about 26,000 districts data set, where we get the median housing value, price of houses, median price of houses. And we have been given a lot of other data attributes like income, population, household, variety of census type of data, right? And we are trying to find out what's the relationship between price and any of these attributes so that we can determine the pricing in the case of a new district or new equation or a new business problem that we are talking about. So let's say somebody is launching a housing program or whatnot, they may want to be interested in looking at it. So it could be a mortgage player, bank, or any of that. Right? So that is sort of the use case, predicting price given a set of other inputs around number of rooms or houses closer to ocean or not, and those kind of things. Okay, so quick recap: regression is about trying to find what is the relationship between the two data points, x and y. And in this case, we have multiple variables, so it's a multivariate type of element, but we have assumed a linear relationship. That means the if x increases, y also increases, right? Now, our endeavor is to find a mathematical equation that will help us define this. And the mathematical equation can be any of these lines, right? There could be many lines we can draw when we plot these data points on a scatter plot. And we are trying to find out what is the best fit line, right? Now, the best fit line is the one which is going to have least amount of error in terms of what's the actual value and what's the predicted value. Now, this line will give us the predicted value, let's say, given the equation, and the actual values or the actual data points that are scattered in the graph. And we are trying to find the line that's going to give us the least error and potentially use that for our future mapping. If there is a new data point comes in, I could quickly say, hey, given a value of x, what could be the y, right? And because the line will give me all of those data points. That's our endeavor. And the equation is something of this nature, where we talk about y equal to mx plus c. There will be some bias and error factors, but we are looking at some kind of factor y equal to mx plus c and so on. All right. Okay, so that's our kickstart in terms of quick background. Then we went, we looked at the 7-step process at a high level, and then I've talked about where do we start. So we start with, we completed step 1 and step 2. Step 1, we talk about framing the problem in the context of business. What's the objective? What am I trying to achieve? Get all your questions from a business perspective. I'm going to just remove this logo and other pieces to make it easy for us as we navigate this mind map. Okay. All right. So we've looked at trying to get an understanding from a business context. What's the problem? What's the benefit? What's the expectation? What are the alternate solutions available, and so on and so forth. So these are the questions you're going to ask. Try and get an answer as much as you can. And then we talk about, okay, given the problem and the objective and what I want to achieve, how do I go about procuring this data? So in our case, the idea is to predict the housing value or the price of a median house, a median price of a house, given an n number of other attributes, right? So that's our objective. Now, from a data standpoint, we already have been, we are using one of these data sets that have been collected, but in reality, in an enterprise situation, you're going to go and collect this data set. You may spend a lot of time trying to find out what may be a good system. It could be an ERP, it could be a database, it could be a file, any of these, right? So, so that's sort of what we are trying to do here in terms of making sure we can go and get the data, and then the landing zone in terms of storage and these kind of things can be there, right? One quick touch point is the target variable and then the other attributes. In our example case, the target variable, like I said, is median house prices at a district level, right? And there could be other variables which are helping us determine that. Okay. All right. So that's a good recap, quick recap in terms of step 1 and 2. Now let's go deeper. So my next step is, now I know the problems I'm solving. I know the data set that I have with me. All right. And then we also introduced you to NIME, which is our no code tool. You don't have to write a line of code there. You just use it to build analytical solutions for business, right? Now let's go to the next step, which is around understanding the data deeper. Now, without understanding the data and preparing it, you can't build analytical models. Okay. So in terms of data analysis, we start with, there are a couple of things we need to do, and we will I'll explain the steps, and then I will also talk about how we do it in the tool, right? Again, from a data standpoint, we start with the big picture. Primarily, we start looking at the input data file and say, hey, what is given to us? How many instances of these district values, which is the number of rows, how many columns have been given to us, what kind of data attributes are there in terms of column headers, what are the data types, is it a number, is it a string, is it a character, whatnot, and what are some of the values, sample values. So you're warming up, you're getting a feel for what that data is, right? Then you have to figure out at a high level, is it going to be sufficient for me to build model? Is there anything of value given the objective that I'm talking about? Now let's say in this case we are talking about determining the price of the house. Now none of these attributes that we have, let's say for example, we have all inputs like, terrain of the landscape or rivers and bridges and stuff like that, right? Which are not necessarily directly related to the housing value that we are trying to look at. Then you may say, hey, this data is not sufficient. I may have to go and look for the right set of data. But given this data set, sometimes you say, hey, look, okay, looks like there is something of value, I can play with it. So I got income here, I have age of the house, I have location of the house and those kind of things. And we all know that these are the parameters that impact the price of a house, right? So we are fairly good with that. Now, once I get a good understanding of how much of data I have, what is it, what is the level, then I may zoom in on the individual attributes. Now, how do I do it? That's called univariate analysis. Univariate is single variable. So now I go and look at what is the distribution of or makeup of the pricing values, right? So we start with the first measure, which is our target variable, which is the price, right? Is it high? Is it low? Are most of them converging around a certain data point? What is the feel for the prices, right? That is the first step. Now the second step is, for each of the other attributes, I want to understand what is the data representing, right? How is it distributed? How the data is made available. So let's say, for example, we look at median age of the houses, right? Now the age of the house can be 5 years to 6 years to 20 years to 30 years, right? Now we want to know what are some of these numbers that will help me quickly understand what this data is, right? So we use statistics from that perspective. Statistics is a very powerful element, and it will help us understand, right? Now from statistics, and I have done separate videos on these topics for you to get an understanding. So there are a couple of things I can do in terms of describing individual attributes. First is measures of central tendency. Now central tendency is going to give me some statistical numbers, right? It's going to try and look at the data set and give me some quick numbers. So mean is nothing but your average. So we're going to get an average age given the data set that we talk about, right? Now I could also do average age by proximity of the house to the ocean, right? So that's one of the variables that have been given to us. So I could do various kinds of averages, but let's say, for example, we start with trying to get what is the average. Median is the midpoint of the data set. Mode is the most frequent value that's occurring, right? Now together these will quickly help us understand, hey, what's the most common age of the house or whatnot, right? Whatever parameter you're trying to analyze. So that's our measures of central tendency. Then I want to understand usually there is variability in the data. Now I can have an average, let's say for example, like I have 10 numbers and my average is 5. The average can be 5 on the back of, let's say, 0 plus 10 can also give us average of 5, or it could be 4 plus 6 plus something else, right? I mean, it could be combination of 5 6 numbers that can also lead me to 5, right? So we need to look at, while we have the averages and medians and mode, now I try to understand what is the type of distribution the data is. And we will see all of this as an example, but I'm just giving you the steps so that you remember these, right? Now, measures of dispersion will help us understand how distributed the data is, how much is converging around the average, are they too far from the average, and so on and so forth, right? So range is a quick measure, just the difference between maximum value and the minimum value when they are sorted. Then standard deviation is how far am I from the mean in terms of when I assume the data is normal, right? And then variance is a square element from that perspective. Okay, so we look at range and then standard deviation and so on and so forth. Now there is one more factor I have not added. Let me just add it here because I think I've included it otherwise. But you also want to look at skewness and kurtosis, right? Now skewness is how is the data more towards the left or the right in terms of, so when the graph is drawn and the data is plotted, where is it converging? Is it converging to a lower end of the spectrum? Is it converging towards is it more towards the average? Is it converging to the right? All of these are part of the distribution analysis, and it will give us a good sense of the data, right? So you may want to look at this as well. Now let's talk about, that is purely by numbers from a statistics standpoint. Then I go and do visual analysis, which is what we'll be doing extensively as well using the tool. And without writing code, you can quickly get a good sense of what the visuals are, right? And the visuals are very powerful. They, at least for me, they have helped a lot in terms of being able to quickly understand. So I can do histograms, which is basically taking a band of values and then trying to plot them. Pie chart, we all know, might have heard about pie chart in most cases. So if it's a categorical variable saying, hey, red, green, blue, what is the distribution of the red, green, blue in that sense, right? So these are the things that I'll be looking at. So there are many graphs that are available, many types of visuals. Do your visual analysis. So essentially what we're trying to do is trying to get a sense for a feel for the data, right? Now when I've looked at these individual attributes, then I can go and look at the relationship between the attributes. So what is the relationship between income and the house prices, age and house prices? And that is one kind of analysis, right? There could be a direct relationship between these variables themselves. So let's say, for example, in our data set, we've been given two attributes. One is total number of rooms and total number of bedrooms, right? Now the price of the house, may go up if there are more number of rooms. There is a high chance, right? And then there's a good chance that the number of bedrooms are also high if the number of rooms are high, right? But that is our normal experience. Given this data set, what do I get? Is this data set giving me that kind of relationship? And we have taken a simple data point here, which can be intuitive, but there could be other complex data sets you may be getting, maybe a machine data or marketing data set and so on, or customer behavioral and so on, where it may not be so evident, right? But that kind of analysis is what we are going to do from a bivariate analysis standpoint, where you are saying, now that I have understood the individual columns and attributes, let me understand the relationship between the two or three variables, right? Now the easiest way, one of the very powerful tool again, is crosstab. Crosstab is, all you're saying is, let's say there are two variables x and y. I'm going to count all these intersection points for the values of x and y, right? So it's basically crosstab analysis as well as and then we talk about correlation analysis as well, where we talk about positive, negative, so on and so forth. So this thing is actually wrong. It should be essentially, give me 1 second. So correlation analysis is it's supposed to be this. I think it might have moved on the back of some mistake I have done, right? Give me just 1 second. Let me just correct it as we speak. I also tend to make mistakes a lot sometimes, right? So okay, all right. So this is, so you're trying to find out what is the correlation. Now correlation means, is the number, are they moving together, right? So for example, if the temperature drops, does it mean that there's a high chance of there's a high chance of snow that's going to occur today, right? If the temperature goes up, the chances of snow coming in will be less. So that's an example of a negative correlation, simple example where we look at, right? But the positive correlation could be that, okay, so if there is a if it's summer, there's a high chance that people will have ice creams more, right? Or something of that nature, which is basically, if the temperature goes up, ice cream sales will go up, most likely, right? If the temperature comes down, potentially the ice cream sales may come down as well. So things like that, which are saying, hey, are these variables moving together in the same direction, or are they moving in the opposite direction, so that I can factor the impact of them in terms of my final analysis. Mind you, all of this is to get a good understanding, so that now when we go and build the model, so that we can predict the price for the future, it's you can then make a good sense of the equation that the techniques are going to throw at us, right? So essentially that's the idea. Second technique is covariance matrix. Now covariance matrix is also a good, it's essentially, again, you're trying to plot a relationship across all of these attributes with every other attribute, right? So that's another quick visual, and we will see all of these and all that. What I would say is, one type of analysis that you want to do is, what is the relationship between the target variable, which is our price or the y, and then these other attributes which are x's, right? So this could be what's the relationship between age and price, number of rooms and price, number of household and then price, and so on and so forth, right? So you may definitely want to do that to understand what's the relationship, nature of the relationship, what is the data telling me by way of analysis, and then between the attributes as well, you may want to do those kind of analysis and so on and so forth, right? So that is the sort of example I've talked about here, and you can go from there. All right. So we have done quick analysis from the perspective of big picture, then univariate and bivariate analysis as well. Now let's go and look at the workflow that we are building. So this is the KNIME tool. I have already introduced you to the KNIME tool in the previous video. If you have not had a chance to watch the video, please do that. In the video 1 of the series, you will find all of these core elements have been talked about. Okay. So we already read this data set. We have this housing data set. Just to quickly refresh your memory, we are talking about a CSV file that's being made available to us, and these are all the attributes that are available. So I have n number of rows and so on. Okay. All right. Now let's begin our understanding of this data set, so that we can go from there, right? Now, right after the bat, you will see that I could quickly get a sense of the summaries of the CSV reader or any of these inputs, right? So while I'm reading, the tool also gives us good statistics, and I briefly touched on it. So let's go from there, right? So I have about 20,000 rows, 2640 to be exact. There are 10 columns, and then these are the columns. So I have, per each row is representing a district, and the averages and the median values in the district, right? So that's how. So there are about 20,000 district or so on and so forth, 2640, and then these are my attributes. So what are the attributes that are given to us which are impacting the price? There's lat long parameters in terms of the like the midpoint or whatever it is of the district, the median age of the house, total number of rooms, total bedrooms, population of the district. So some cases it's high, some cases it's low, number of households, right? I mean, so how many families are there or whatnot. Then we talk about median income, median household housing value, and then ocean, proximity to ocean, and so on and so forth, or proximity to bay, and all of this. Then I talked about filtering. So you can quickly, if you want to just continue with the tabular analysis, you could quickly go and filter this, and you can say, hey, look, let me go and look at all the inland variables and then see what the values are, like, mostly what are they talking about, or what are the ages and so on and so forth, right? So this is, if you're comfortable with row tabular analysis, then you could do this, and then you can sort of remove that, and then you're back to the normal, and then you will see these things, right? Now there is also a quick statistics available. We're going to look at statistics separately, but what I would suggest is, this is a good way for you to get a quick sense of what this is. Now the statistics, if you remember, we talked about, for each of these variables, I want to get a quick sense of what the numbers represent. So we talked about measures of central tendency, which is mean, median, mode, and we can see all those values. Okay, so let's just take one and then look at it. So now I'm looking at the median age of housing as one of the parameters, right? So there are about 52 unique values, even though we have sort of 20,640 rows. You will see there are about 52 unique values. That means the age is typically in the increment of 5 years, 6 years, 7 years, whatnot, right? But there are 50 of these. The lowest being 1, that means there are new houses, and then there are 52 is the maximum age. That means there's a house which is 50 years old, right? That kind of aspect. Now the quantiles tell me quickly as to what is how much of the values are falling below a given percentage, right? Now 25% quantile means, in this case, for example, 18 of our age values are falling below the 25%, right? That means 25% of my coverage is given by within the 0 to 18 type of age values. Then 50% of the values are falling below 29, right? So that means most of my ages are below, so my minimum is 1, so 1 to 29, right? And then from 29 upwards of 52, I can see values which are another 50%. Then let's look at 75%. That's why in a similar fashion, you will see that 1 to 37 literally covers 2/3 of my value, or 75% of the value, right? So you get the gist. Essentially, you have a lot of these statistical elements that are available for us to quickly get a sense of this. So I can quickly get a sense, right? So now average age is 28 or 29, the midpoint 50%, right? I mean, that's roughly about, so mostly, let's say, for example, 29, 30 years of age is where most of the houses fall. And then we talk about there are other parameters that will be available for us to look at, and so on and so forth. And then we are talking about 10 most common values, and you also get the deviation. So standard deviation also allows us to interpret what is the spread of these values, right? Now we will do a quick visual analysis, then that will be clear. So likewise, you could, for example, give me 1 second. I think I minimize. So if you by mistake minimize, just go and maximize it and zoom in, right? Then similarly, I can do it for total number of rooms, bedrooms, and so on, right? Now I want to cover one aspect before we go to the visual part of it. You will see that there are about 200 odd districts where we don't have this information around bedrooms. Now this is slightly far better in terms of the data, because only one of these attributes has missing value. But in many cases, in reality, when you go to clients, you will see that there are a lot of missing values potentially possible, right? So you may have data for certain segment, but for the other segment which is coming from a different system, maybe you don't have those attributes, and so on and so forth. So you may want to make sure you're handling it. So we need to handle these missing values as we go along, and that is in our preparation step. But keep in mind that where the missing values are occurring, and so on and so forth, right? So that is one part of it. And then you also make sure you understand the data types, right? Now in this case, most of this is numeric, therefore it's all numbers, and one of these is string. Now string is obviously, like we looked at, it's proximity to the ocean, and there are a set of values there, and that is basically a categorical variable. Okay. Now in case of KNIME, it's a very powerful tool where we are able to quickly model the steps, and I can use it to explain to my business or anything like that. If you have a Python code, it's going to be quite difficult to explain to somebody, right? But that's not very hard. You can document and so on. But this, to me, graphically, it's easy to explain, right? Now, one of the reason it's powerful is we go through a lot of steps, but I can combine a set of steps and then I can group them together, right? So this is what we talked about in the previous video, where I can create a meta node, and the meta node is nothing but grouping of set of steps, so that I don't have to worry about those steps in terms of detail. I know that this is what I'm doing, this is the input and this is the output, and there could be 10 steps below that, right? And this quickly allows me to get a sense of the overall picture and without getting clouded by this, right? And then we also talked about component. So if there is a reusable element, I can go and create a component. Okay. Now let's look at the meta node from a data analysis standpoint. So this is our third step, and this is how I've structured it a little bit better for you to get a sense. You could not necessarily have all of this. You could also have a sequential flow of these variables and whatnot. So we can easily drag them, drop them wherever we want. And these comments are something that I've added. So you can add a comment by saying, hey, here's a new workflow annotation, and that will allow us to add the comment. Okay. All right. So those are basics of the tool. Very easy for you to get going once you download and install, right? And which I've talked about in the video 1. So if you have not done it, please do that. Okay. All right. So we're starting to talk about analysis. We looked at the statistical part. Now let's look at the visual analysis part of it, right? Now we talked about histogram being a very powerful tool in terms of analysis. Now one thing I'll say is, if the node is executed, that means if I have executed the step, it will turn green. If I have not executed the step, it will be in yellow, and I can go and execute it, right? And I can also execute all of these one shot together, so we don't have to wait for any of this. Okay. All right. So my first step is to go and look at the histogram. Now first let's look at, for every node, the configuration, and then we will look at the output, right? So the configuration, you can either double click or click on this dial type of a button, and you will come here. Now you're saying, okay, I want to do histogram. Now histograms are nothing but how many values are going to fall in a particular range, right? Now that is what is binning, and it will be very clear when we look at an example. So you're saying, hey, how many values are falling between 0 to 5, 5 to 10, 10 to 15, and 15 to 20, and those kind of things, right? Whatever is your grouping, because sometimes there could be like 0 to 50 was the spread here in terms of age, right? You don't necessarily want 50 values, because that's not of value to us, right? We don't want accurate age numbers for our analysis. So by and large, we know if the house is, let's say, between 20 years and 25 years, most likely maybe the price is similar, right, for that range. And then, but then when it goes to 40 and 45, then the price variation could be higher, things of that nature. So you may want to look at the grouping that will be more suitable for your business problem, right? And that is called binning. So my binning variable is this. I'm starting with median age. I could start with any of these variables, and I can do when I'm plotting the histogram. So just start with one. There is a interactive histogram where I can change this value. I will show you how we can do that. Just start with one of these variables. Now what am I going to aggregate? So histogram is nothing but a range of values and then the count of those, right? Count of these values plotted in a graph. Now what am I counting? That is the variable that you're going to indicate here. It could be number of rows of data sets. How many records or how many rows are falling between 0 and 5, how many records are falling between 5 and 10, and that kind of stuff. Okay. All right. And then you can choose to say, hey, am I going to do a quick, let's say you had millions of rows, you're analyzing like a IoT data or temperature coming from a machine or something large, right? You may want to limit the number of rows that you want to look at. But in this case, the data values are not very many, so we can quickly look at all of them. Okay. All right. So now, and then this flow variable is a common element from a tab standpoint and so on. So for now, don't worry about any of the others. you can just get started with the config. So just indicate what is the histogram you want to go with, and let's get started. Now you right click on it. So you go and look at the widget and right click. You will see this open view as an option, right? Now the open view, give me 1 second, there's some problem here. Okay, so we do have all of these inputs, histogram. Let me just see what is going on here. I'm just going to go and reset this part. Let me see if one of these other histograms come up and we can look at it. So these are widgets. So essentially, okay, so that's working. There's no problem there. So let me just redo this histogram. So how can I go and redo this, right? So if you look at search for the widget, you could say histogram, and then you will get this histogram element here. Now I can go and look at interactive histogram where I'm interested in this. So I'm just going to drop this link. For some reason that's not working. There could be a reset issue, but which I'll figure out later. So I'm just going to redo this a bit. So all we have to do is let's just go and say, hey, display all the rows and do my binning on this value and then the row number. Probably row number could be the issue, but let's see how it comes. Okay, all right, so I'm just going to do that, and then now I'm going to execute it. It executed well. Okay, all right, so some issue might have been there. Okay, so now I'm looking at this, right? So I started with age. Now I'm doing a quick analysis. So sometimes you may want to adjust these parameters and these values so that your binning is coming well and so on and so forth, right? Now I can go and like I said, right now this is an interactive visual. I started with age. I can go and look at other parameters, and we will look at it in a minute. But that's how interactive histogram allows us to play with these, right? I'm looking at row counts, and that's what I'm starting with. Then let's look at the bin number of bin settings. Now typically if the values have a large range, you may want to have a large number of bins. Otherwise you will see many of them are congregating around a certain value and so on. So you can play with these number of bins. Let's say I go with 40 or so on and so forth. Now you will see that so one is to get a sense of the distribution. So here I can see that there are some values which are occurring there are some peaks at certain points, but there are also lower values in between, right? So that means there is some common age. So for example, if I were to look at, let's look at price as a parameter, because price is a key thing that we're looking at. So let's look at the housing value and the housing prices, right? Now let me maximize this. So you will see that now my housing value is so these are ranges. Now let's say for example they are in thousands or whatnot, right? So somewhere around million and 1.2 or whatnot, I see some values, and then there are some values around 800k. That seems to be very high frequent as well. Now the lowest housing values seems to be around let me just zoom in here. It could be I think I need to find out a way to hover this. So let me just highlight the select. Okay, so you can see these values. So lowest seems to be 150k. I mean, it could be an old house in some place, right? But then there are other values and so on. Okay, so you get the gist of it. You can analyze the data point. You get a sense of how the pricing is distributed, and each of these variables we need to analyze and look at it. Okay, now one interesting point is this value at the top is capped. So that means closer to 590k or so. So this is basically we need to divide this by whatever it's in 100,000s, right? So it's basically around 490k or so. Most of my values are coming, and there is nothing more than that, right? Now that may be an indication that there are houses which are priced above this, but maybe somebody didn't capture this data point, or something happened and they've capped all of these values here, because as you can see, there are as the value increases, as the price increases, the number of houses decrease, but then there's a sudden bump, right? So that can't be a random act. That must be like a systematic issue that could be there. So we may want to find out from a business standpoint what that means. Do I go and treat this separately? Do I go and collect the data of houses which are above the 500k or 490k type of mark, or do I ignore these because they are going to now impact my equation or the prediction, right? So do I drop them? Do I go and get additional data set? What do I do, right? So we need to look at a treatment for something of that nature. And so essentially that is sort of what you're trying to do from a analysis standpoint. Now let's look at other pieces. So for example, now I'm looking at median income, and we can see that the income starts with let's say, for example, what is this? And I think there should be a visual to show the bin outline, not the bin outline, bin. So there should be a element that should come up mostly, but let's okay. So we will figure out that part later. But what I'm saying, I don't need this outline here. So what I'm saying is, you could just select one particular value, look at what are the elements there, and so on. You can zoom in as well and do those kind of things, right? And then clear those highlights. For example, okay, unhighlight the selected or whatever it is, right? So basically, it will give me all the values here. So you can say there are 242 rows where the income is between let's say this, it can't be $3, right? So it has to be, let's say, a multiple of 10,000. So maybe 30,000 and 34,000, right? So 30k US dollars and 34,000 US dollars, or something of that nature. You will see that the income falls, and there are about 2,000 of these values, right? And so you will be able to zoom in on any particular value if you want, and keep clicking, and then you will be able to go through these analysis as you want. Now let's say I want to look at what is the higher end of the spectrum, right? I could go and look at, so maybe 146, 150k is sort of the higher, and there are about 52 values on an average, and these are averages of the district, right? It's not like individual numbers. So you will see on an average, most of the data point is somewhere between, let's say, this range, for example, 19,000 and probably, let's say, for example, here, right? So around 52k or something like that. So most of my values are here. Now we also talked about looking at whether the data is skewed or not, right? So this is obviously skewed. So obviously you will see more values closer to the lower end of the spectrum as opposed to the higher end of the spectrum, right? That's what it means. And so just keep that in mind as we go along, right? Now I can do similar analysis around, we did the housing value, we look at population. So many of them have, so there are a large number of districts which have, so what this means is there are a large number of districts which have a population of, let's say, whatever that unit is. We can go to Kaggle and look at what the original data set and look at what they meant from a unit standpoint. So whatever is the unit, let's say this is million, right? So about there is a very high concentration of population in certain districts, but then there are many districts where the population concentration is less, right? So mostly you will see, or there's a common type of a distribution around population, maybe the cities and rural areas versus, and so on and so forth, right? So you can do all of these. It's more from your business experience, and then how you're looking at it, and all that. Now let's quickly look at categorical as well. Now I'm doing a similar plot and then saying, hey, what is the value from a so the categorical values, like we said, they are basically 5 categories that they've given. Is the houses, are the houses near, how many are near the ocean, how many are near the bay, how many are inland, and so on and so forth. We know location is a big parameter in terms of pricing, and that's a key value as well, right? Now this is all histogram, and I could do row value, sum, average, all of these things, and you can see that the power of visual is quite good. I didn't have to write any code. I just dragged and dropped a widget, and I could literally go and look at it. Now this was an interactive visual where I'm going to drop this original one. So this was an interactive visual where I looked at all the columns. Now I could do a similar, I could, if I wanted to just do a histogram of just one of these values, I could do that as well. So you could have a histogram JavaScript. So one of these, and then you could just zoom in on one particular value. Now this has a different feel to it, but so this is another similar visual. It's just that it's displaying it in a different manner, but I can't play with the bins and variables, right? So once I refresh, I can get this. But what I can do is I can add a lot of other pieces around what the title is, and so on and so forth. So therefore, so I've said, hey, the x-axis is this, title of the graph is the target variable analysis, which is the housing price analysis, and so on and so forth. I could put whatever I want. And then what I can, sorry, I wanted to do one thing here. So then I think you can go to, there's one option where I can go and save this as a picture, right? Let me just say where that is. If I right click on it, my output port can be like an image. Okay, so I can save this as an image, and then I can put it in a PowerPoint as part of my analysis of the data set, and so on and so forth, and you can do these things, right? So these are, most of these widgets will allow you to store, or you can put it under another widget which is going to write to a file folder in terms of image, and so on and so forth. Okay, all right, so that's again your histogram analysis. I'm doing detail analysis, so you have some observations and you can make these notes. Since we are learning, I'm just making certain notes that I as example notes. There could be many other observations that can come, but treat it as a quick example. Right now we saw that quick analysis of rows and columns, most of the data is skewed, right, and that's what we saw. Now I'm doing target analysis. Now in the target analysis, like I said, that's an important analysis. You want to make sure that is there, which is the house prices, right? Now there I can see the ranges from 19K to 495K, which is obvious. There could be high-end homes as well as district with high-end homes, and then those with are more in the rural or other areas, right? And then you can see that there's a capping of values around 495. We saw that. Then we saw that around median housing income, and you need to multiply that by a certain value so that you get the underlying unit, which is called scaling, right? So you're just making sure the original unit is there, and so on and so forth. Okay, now let's do two more analysis, and then we will go from there. Categorical variables are typically well suited for like a pie chart type of analysis. So I'm just looking at, given 100, which is the full circle, right? What is the percentage distribution of each of the categories, right? Now in this case, there are again, you have many types of pie charts. You can play with it, but by and large, you will see that I've just plotted this, and this is a better visual than the histogram for a categorical variable. Now I can clearly see 45% of my districts are whatever in this variable category, 32% are inland, about 13% are near ocean, that is about 2000 of these districts, and so on and so forth, right? So I can do a quick analysis and say, hey, look, okay, all right, most of them are inland, that makes sense, but there are some districts which are more closer to the ocean, and so on and so forth. Okay, all right, so pie chart analysis is also there, so it's easy. You can just search for pie chart. There will be variety of these. Likewise, you have scatter plots, you have bar chart, you have many of these, right? And you can also do a heat map, and so on and so forth. I'll be covering these in separate videos, but for our regression analysis, I think you're pretty much okay with just the histogram and the pie chart analysis that we looked at. Okay, now we have been given a parameter around latitude and longitude. I just want to show you one more visual where we can go and look at this. Right now, some of you might be familiar with the California map. Now when I plot this longitude and latitude, the way the distribution comes is this, and I can see this, right? So there is concentration of values. That means the density is very high closer to certain areas. So for example, hypothetically, I could say, hey, these parts are more around San Francisco and the Bay Area type of region, then I can see some concentration around Sacramento and that kind of a split. Then further around Napa or Napa Valley, you will see some concentration, and then below around LA, there is concentration, and then San Diego and all of that, right? So you can see that, so this is a quick view of where these values are and how are they coming along and so on and so forth. So that gives you a good view. Now I can also plot. I can then, so these plots can also be. You can also include. Give me 1 second. Let me just see if I can include that, right? So now this is my access configuration. Now I could also include color values and so on and so forth, right? Not this one. View controls. Yeah, there is one more value I can look at. So the density columns, I could not this one. So there's one more where so essentially what you can do is you can plot other things in terms of like look, overlay sort of prices on top of this. So this is just a lat and long that's being populated, but if I overlaid prices, you could do other kind of analysis and say, hey, show me the value in terms of certain other things, and then like I said, around title and X and Y columns and all these things can also be looked at. Okay, all right, so we are in the analysis mode, so this is good enough from our analysis standpoint, and you can continue to do this as we go along and so on and so forth. Okay, now I added this math formula which is one of the widgets, just to say, because in the input we don't have a row number. So row number is, let's say I'm talking about something that's uniquely going to identify an instance or a row. Now in this case, if we had the district number, for example, district ID or something like that, then I didn't need to have this row number. Right now the row number is useful for us when we do the analysis and when we want to trace the data back and see, hey, particularly after we build the model and then we predict, we can go and check certain things, right? So it's useful in that sense. So I'm adding a particular row number, and the row number column comes up at the last, as you can see, and it's just a sequential number that's coming in, and because all we talked about is a row index, right? Now I could have anything else, but it could be any formula, but essentially that's what you're doing here. Okay, all right, so that covers your exploratory data analysis. Now how do I go back to my original workflow? I just, at the top you will see this ribbon, and I could have another level and so on and so forth. I think I have not tried that, but essentially you click on this ribbon and then you can go back to the original, right? Now I had zoomed in, I gone into the details of exploratory analysis, all the target variable analysis and statistics and all of that, and then now we are ready to say, hey, okay, now I got a good sense of this, right? The prices are ranging from 19K to 495K, XYZ. Most of these houses are in the range of 29 to 30 years and so on and so forth, right? Whatever years you're learning and conclusion, you're able to do that, and you can even make a note of some of these things here. All right, so this is detailed coverage of exploratory data analysis, and there could be other things that you could look at. I've talked about common things that are possible here in this case, and so on and so forth. Okay, and like I said, you can take a snapshot of this, you can keep visual and use it your analysis, because some of this you may want to then go back to business and start talking to them as well, right? Your analysis, and now you don't want to bore them with every kind of analysis, but there are key things, key graphs that you may want to pick and say, hey, look, this is sort of the distribution, this is my observation, and therefore this is coming in. All right, okay, so we will stop the video here. For this is the second part of the video where we have gone through the exploratory data analysis. Now let me pull the mind map again. So we have come to step 1, step 2, data acquisition, which is where we looked at the CSV file, and now we are looking at data analysis, and we have got a good sense of how the data is distributed. Most of them are skewed, most of them are falling in a particular range, and so on and so forth. Okay, now I didn't do and we looked at relationship analysis and so on. We will do a correlation analysis as well as part of the next step, but you could continue these kind of analysis. So as we did like visual and statistics, and all of this big picture good stuff. Okay, hopefully you understood how we have gone about analysis. There are a lot of options available, very good tool, and you can, without writing any line of code, you are able to quickly get to it, right? In about half an hour we were able to do a good analysis of the data set and so on and so forth. Okay, if you like this video, do send your comments, or you want me to add certain things, or you have another observations, please do write your comment, and then let's go to the next step in the next video, where I will, now that we have understood the data, we're going to do one more step around preparing the data, because we saw that there were some missing values and so on and so forth. Data preparation is a key part of any data science life cycle, right? And that's a key step. So we will look at that, and we'll spend some more time in the next video around that. And then we will go to model building, and then fine tuning the model and so on and so forth. Okay. All right. So there you have it. Hopefully you like the video. Do comment, and let's talk in the next video. Thank you very much. Bye bye.